Today I will present matching method. It's can use for non-linear situation. For example, when we have two signals such as a triangle function, like this sine function or cosine function, but sometimes if we can sample the function and we in engineering the function is decreased. So, but sometimes we may sample this point, maybe lose this point and unit this point. So we may get a signal like this, and but have different frequency, and maybe the same function when we sample is this. They have the same amplitude, but maybe have a different sample frequency. So we may think it's not like the original function. In this presentation, I will propose a method. I will present a method to solve this problem. It's that it's like this. You will have two signals. The signal signal maybe have different lengths. So in this one we can we match this point, this match this point, this and this point, this match this point. This can have a match. This I will practice the method to have this best match. I mean sometimes. Maybe it's not like this linear frequency. Maybe this is a sample frequency, and this is another sample frequency. But I have the best match. I will define some.
You want to find the matches?
Yeah, matches. What do you mean? There are two signals. But they have same shape. If we match one by one, maybe we will get a bad result.
Match the samples from each signal?
Yeah, no, I mean, just have the best match. The volley match the volley, such as this, give a method to obtain this effect. Method, I will first suppose that I have two signals. This was this x and y. They are all vectors. Another thing is that I will have another vectors. This vector is P, stand for point. Have this best match field such as this length have L. The length of this vector is L. So this is the best match. I mean, can you have this? The two signals we can look at in the two-dimension graph. For example, this is X signal. This is Y signal. This for each sample point. For example, we can have a different sample point here. Okay, the Y point. Now we can form a grid like this. In every intersection, we can define Euclid or other distance, just as normal is okay. This is the sample point to the coordinate. This is the point section value can define as this. This is the norm function that can be Euclid function or any other, just to reflect the similar of the 2 points. So we can have every point here. All of the points we can have n by m points and have so many values here. So I will find a path from this point to this point. This is the start of the 2 signal, and this is the end of the 2 signal, and find a match in the path. Here, for example, this path, or this path here. Together, every point is selected to have best match to the 2 point. So, how do I get this? I will define the routing. The first, it must start from this point and end at this point. So, the start point here and here must be first requirement is this is the start point, and this is end point. And another requirement is that because signal is in the time increase, we can have this function root, because the time is the feedback for this signal, and this root because this is time back. So we have 3 roots for every grid point. First root is this direction, or this direction, or this direction. There are only these 3 roots is allowed. So we can have must the preceding point and the present point have these three roots.
What's the PT and PTA?
P here, this point just stand for this vector and every vector here.
What's
This
the
is
P?
P1,
Okay.
P2, P and L. This is the L vectors.
That was a PTL or PTN?
P minus 1 and sorry. It's just like this. This is the 1 to L, and this is roots. You can just simple. The simple is that from this point you can go to this root, three roots along. Just this, repair this mean this function. So first for point we have an iteration. If you find one by one way, for example, you find each way, and you compute the minimum. When the size is increased, you have an exponential decrease. The computation is very complex. But I will present a method. It has the complex of only n by m to find the best match. It's like this. First, I have already computed every point, the value here, and second, for each value here, I will first for this root. It's only have to from this point to this point. It have another choice. I will write. For point, I will use
I think that was the YM.
for example, this point is ij. I will use dij stand for the value of this point. Too simple. I will not use the xy here.
That was the YM, not this M. Or the Y.
Why?
Yeah, the second one. The Y is equal to Y1, Y2, till YM, not XM.
Oh, sorry. So I will have the 2 points here. For point, this stands for this value. This is the distance here. I will define this value as this to the point the value matters the last 3 possible routines values and to get under the minimum of the three values. For example, for this is defined as the communicate values. It can use as the present this value plus the three of the the minimum of the three values to get these values. So we can from this function we can iterations. For this point, this only has one. For the column here, it only have one possible routing, just like this. So we can first compute here. Similar, this can be queued. Then in other point, we can start iteration from this column and this here, and every point we will get a communicate value. This is best match of the overall. To understand every mean we get a mean value to get the best match here. So after I get the best match here, I can get we can have a better evaluation of the two signals. For it's just like this. For example, maybe this routing is better than this. And if we want to get the order of the point, we can get a feedback. For example, we from the point we every point here we can here I can feedback to get the routing because I got get the dxy is the minimum of the overroute. So when we get feedback, I will choose according to mean. We'll choose which is the three of the minimum. For example, this is minimum, so I put here, and from this point I will choose the which is the minimum. If this, I will here plus the external, and get the match. So for every point, I will select the two used as signals match points, and then this is very simple method, but it has a good effect. It's used in speech recognition and have very good effect. It can solve these linear problems, and also as a matter of fact, when I was pursuing my master's degree, I have used the method for my projects in gate recognition, and have best effect. Recognition is very good, especially for tools, image or signal. If they have you sample in different frequency and you found to have a bad match with a good match, this method is good. So that's my presentation. Yeah.
You said this one is the best.
Yeah, its best match is defined.
Why?
Because every step here, I will choose the minimum.
Yeah.
So minimum. So if the philosophy behind the signal that I will find some points from the two signal. Maybe the signal this point I can use two, for example, match here. But whatever you match, I will find one match is this match to this match have in this order have the least values, the two signal, the least value of the two signal, the least difference. I will use this as so when you impose this on this signal, it can have a best match signal.
Did you compare this method to another one?
Yeah, I have contact derived. It's very good method. You can DTW is especially in different frequency signals recognition. For example, if an image somehow compressed, some is normal and some is broad, and you have a normal picture, then you can compare use this method, you can match point and alignment well at order. Just use this method. Just use this. But this is the mini idea is this formula.
You mean although if the size of the signal they're not same, you can just use this method to find the samples?
Just find the
Yeah, because for example X and Y, these two signals, they don't have the same size.
Yeah, same size.
So but you can just use it.
Yeah. Whatever is your size, it doesn't matter. It's maybe he used. I said maybe he used the point to succeed the point I select here like this. It's non-decrease. The point maybe this point have used twice match.
Yes.
Yeah. So it doesn't matter the length. It's okay. For this, it's just used to solve linear, not equal length signal comparison.
It's interesting.
Yeah, simple, but I think it's useful. So that's my today presentation.